All right, so I just wanted to take a minute to go through the question that we went through in class. And even if you saw it in class and you're perfectly okay with what happened in class, you probably want to skip ahead to the end because I am going to talk about a couple of things that will simplify that last process for you. All right, so here we go. We've got the region enclosed by a linear graph and a quadratic. So if we just make the assumption to start with, and we'll find out later whether this is a good assumption or not, but if we just make the assumption that we have some type of quadratic graph that then has a linear graph which intersects it, really there's only a couple of different options. One is that it intersects at two places, one is that it intersects at one place, and one is that it doesn't intersect at all. Now, in the last two situations, you're not going to have a region enclosed by the two graphs, right? If you just have this, then there's nothing that's completely enclosed by the two lines, so therefore it wouldn't really be able to answer the question. Same thing without boundaries on the sides, same thing if it doesn't connect, it just goes on and on forever. Now, if it gave us boundaries on the side, obviously we could now consider this situation right here. But given the situation, since it's asking for the region enclosed, we're going to have to assume that it looks something like this. All right, so what we need to do is we need to find the areas, because what we're gonna take this from here to here, right? Because that's the region enclosed. This is what we're looking for. And so it starts at this x value where they intersect here, and it ends at this x value where they intersect right here. So what we need to do is we need to find those points of intersection. So of course to do that, we're just going to go x plus 2 equals x squared plus x minus 2, and then we'll rearrange it. We'll subtract the x, we'll subtract the 2, which ends up giving us 0 equals x squared minus 4. Now from there, I should be able to factor it to x plus 2, x minus 2, which means that x equals 2 and x equals negative 2. Now this is very similar to what we were doing in class when we were looking at the x-axis, because remember when we were in class and looking at things bounded by a curve and the x-axis, we were looking at this area right here, and when we did that we found the intersection. Now we were saying, well, let's find the x-intercept, but really what we were finding was the intersection of our line with the x-axis. So really it was exactly the same as what we're doing now. It's just now we have two different functions rather than one of the functions just being the simple x-axis over here. Okay, so we'll continue with this idea. We're going to go from negative 2 to 2, which just means the integral. Now for this whole region, the linear graph is on top. And so we're going to do the integral from negative 2 to 2 of the linear graph, which is x plus 2 dx. All right, and just like here, in this one, that was it, because x equals 0, we didn't really have to subtract the 0, right? In this situation, we're going to subtract the area of the quadratic. So subtract the integral from negative 2 to 2 of x squared plus x minus 2 dx. Now, at this point in class, we didn't really recognize the fact that these two integrals are exactly the same integral. Now, you learned in class that the integral of f of x plus or minus, not f again, g of x dx can be rewritten as the integral of f of x dx plus or minus the integral of g of x dx, right? So we know that we can do this and split it up. Well, if the integrals are exactly the same, we can also put it back together. So that's what I'm going to do here, is instead of having the area is equal to these two integrals, I'm going to rewrite it so the area equals the integral of negative 2 to 2 of x plus 2 minus x squared plus x minus 2 dx. And so essentially I've just put them together. Now I can combine that, which means in the end, I'm only going to have to do one integral. So I've got negative x squared, I've got x minus x, which would be 0, and then I've got 2 minus negative 2, which would be plus 4. And so there we go. From here, I should be able to just take the integral and solve it. So this is going to become so the x squared will become x to the third and put 1/3 in front. It was negative, so negative 1/3 x. And then the 4, of course, will become 4x. And this is the antiderivative, which we will integrate from -2 to 2. And so now we'll just go ahead and plug it in. We'll do the fundamental theorem of calculus, which is FB minus FA. And so we'll take this and we'll go -1/3 times 2 cubed plus 4 times 2. And then we will subtract -1/3 times -2 cubed plus 4 times -2. And so from there we should be able to simplify it. Note that this is significantly easier than what we had before. And so we'll go ahead and this will be -8/3 plus 8. And then this will be -2 to the third is -8 times 1/3 is 8/3, which will be minus another 8/3. And then minus, negative times A would be plus 8, which means in the end I have 16 minus 16/3, which is going to be 32/3. All right, so there you go. We went through and we found the area enclosed by two graphs. We simplified it by putting the two integrals together, so I only had to do one integral instead of two, and we finished with the final answer. All right, hope that's helpful, and good luck with your homework.